Hello everyone, my name is Atish and topic of this learning video is eigenvalues and eigenvectors. In the last learning video, we have seen eigenvalues and eigenvectors for the matrix of order 2 by 2. In this learning video, we'll see how to find out the eigenvalues and eigenvectors for the matrix of order 3. So as you all know that today's teaching learning process is application oriented. So let us start with the application of eigenvalues and eigenvectors. So the applications are: number 1, communication system; number 2, designing bridges; number 3, designing car stereo system. So let me tell you these interesting applications of eigenvalues and eigenvector. Communication system. Eigenvalues are used to determine the theoretical limit of how much information can be transmitted through a communication medium like your telephone line or through the air. This is done by calculating the eigenvectors and eigenvalues of the communication channel where we have considered the communication channel as a matrix. Next is designing bridges. The natural frequency of the bridge is the eigenvalue of the smallest magnitude of a system that models a bridge. The engineer exploits this knowledge to ensure the stability of their construction. It is so fascinating to see that there is an application of eigenvalues and eigenvector in designing car stereo system. Eigenvalue analysis is used in the design of the car stereo system where it helps to reduce the vibration of the car due to music. So as we have seen these applications, this communication system, so those students who belong to the CIT department or electronics and telecommunication, their applications covered in the first one. Those students who belong to mechanical and civil engineering, their application cover in this, and those who belong to electrical and electronics and telecommunication, their application cover as a in the third part. Okay, now let us see what are the basic terminologies required to understand the topic. So the basic terminologies are characteristic equation, eigenvalues, eigenvectors, and modal matrix. So let us see all these things one by one. So what is characteristic equation? So if we have a matrix of order n, then the matrix A minus lambda I, where this lambda is any scalar quantity and this I is an identity matrix of order same as the order of A, then this matrix A minus lambda I is called as a characteristic matrix. Then what is characteristic equation? When we take the determinant of this matrix and equate it to 0, we get the equation of characteristic equation. Okay. Now the next thing is eigenvalues. So the roots of the characteristic equation, determinant of A minus lambda equal to 0, say lambda 1, lambda 2, lambda n, are called eigenvalues. Now let me tell you a few remarks about the eigenvalues which will be handy in the competitive examinations. So the matrix of eigenvalues is called as spectral matrix. The sum of the eigenvalues is equal to the trace of the principal diagonal elements of the matrix. Okay, so suppose you have a matrix of order 2 by 2. So how many eigenvalues? 2 eigenvalues. Take a sum of those 2 eigenvalues. That sum is same as the sum of the diagonal elements, namely trace. Next is eigenvector, a non-zero vector x such that matrix A minus lambda I operating on x is equal to 0 is called as eigenvector. Let me tell you, this is not a determinant sign, it is a matrix. Okay, because students are so many times very habitual of writing this as a determinant, which is not the case. And the very important thing about the eigenvector is it is non-zero. Okay, many times I see while evaluating the assignments or the answer sheets, the students are writing x as a zero vector, but by the definition it is a non-zero vector. So how it can be a zero vector? Okay, so take care of this x should be a non-zero vector. Next, one remark about the eigenvalue that I have left. The product of the eigenvalues is equal to the determinant of the matrix, where what is determinant? Unique value associated with the matrix. Okay, so we have these remarks about the eigenvalues and the determinant and trace. So as I said, those students who are very much interested in Indian Engineering Services, that is IES, or gate examination, so in that examination you may encounter some questions on the basis of this remarks, depending on determinant, trace and eigenvalue. Sometimes what happen in the examination, will be given a trace and determinant, and with the help of these two, trace and determinant, you have to find out the eigenvalues without knowing what the matrix is. Okay, so that is the beauty of these remarks, that you don't know the matrix, but you know the determinant and trace of the matrix, with the help of which you can able to find out the eigenvalues. Now next is model matrix. So simply speaking, model matrix is nothing but the matrix of eigenvectors. Okay, suppose you have a matrix of order n. So how many eigenvalues? N eigenvalues, and there would be how many eigenvector? N eigenvector corresponding to these eigenvalues. Then the matrix obtained by eigenvectors is called as model matrix. Okay, the next slide is very important because the slide is about the working rule. So what you have to do is, the very first step of working rule is write down the given matrix. Second, find the eigenvalues. Next step is find eigenvectors. Next step, write down the model matrix, and at last you have to find the diagonal form for the given matrix. So if all these things are clear to you, we are eligible to solve the example. So example number 1 says, find the model matrix B and hence find B inverse AB for the corresponding matrix A. So we are given a matrix A, and how many parts we have to do? We have to do two parts. First one is for the model matrix, so you have to find the model matrix, and then you have to find B inverse AB. Okay, so following the steps of working rule, what is the first step? Write down the given matrix, and then we have to find out the model matrix. So model matrix is matrix of eigenvectors, so we are going back, okay, reverse engineering. So for model matrix we want eigenvectors. Eigenvectors can be found out for eigenvalues, and eigenvalues can be found out by characteristic equation, because eigenvalues are nothing but the root of the characteristic equation. So eigenvalues are given by, I have written the characteristic equation. Now writing down this is not tough. You just have to write down the given matrix, subtract lambda from the diagonal element, and rest of the element as it is. Okay, now as you can see, we have a determinant of 3 by 3. Okay, you can solve this manually, but that will take much of your time. So let me tell you a trick. So as the matrix is of order 3, so you'll be getting a cubic equation in this case, which is lambda cube minus s1 lambda plus s2 lambda minus determinant. Okay, so what is s1? S1 is trace of the matrix, and what is s2? S2 is sum of the minors of the diagonal element, and what is this? Determinant of matrix. Okay, one remark, every equation follows the alternate plus minus sign, so it is like plus minus sign. Okay, so what is our objective now? Our objective is to find out the trace of the matrix, then sum of the minors of the diagonal element, and matrix A. So let us go back to the previous slide and see how to get these values. Okay, so what is trace? 9 minus 1 minus 7. So 9 minus 8 is 1. So what is trace? trace is 1. Next we have to find out the sum of the minors of the diagonal elements. So how many diagonal elements are there? 1, 2, 3. 3 diagonal elements are there. To find the minor of this diagonal element, you just remove this row and this column and take the determinant of the remaining element. Likewise, to get the minor of this diagonal element, delete this row and this column and take the determinant of the remaining element, and likewise. Okay, so what is trace? Trace we have found out 1. What is S2? S2 is sum of the minors of the diagonal elements. So when you solve this, you'll be getting 4 plus 0 minus 6. Now this is the values we are getting, and only genius can solve this type of equations. So what is the answer? The answer is minus 2. Okay, and so we have found out S1, we have found out S2, and now you can find out determinant with the help of the trick that I have already told you in the previous video lectures, or you can make use of calculator to get the value. So determinant comes out to be 0. Okay, now substituting all these values of S1, S2 and determinant in this equation will get a new equation, this one. So as you can see, we have a cubic equation where the constant term is absent. So you can solve this manually by taking lambda common. When you take lambda common, you remain with the quadratic equation, and then you can solve the quadratic equation. So how many eigenvalues? 3 eigenvalues. What is the order of the matrix? 3. Okay, so there is a direct relationship between the number of eigenvalues and the order. So what we can say, number of eigenvalues is same as the order of the matrix. Okay, so when you solve, you'll be getting lambda equal to 0, lambda equal to minus 1 and lambda equal to 2. Now this is the second step. We are done with the second step. Now we have to find out the eigenvector. So let us define x be the eigenvector corresponding to eigenvalue lambda such that matrix A minus lambda I operating on x equal to 0. Okay, so you have this matrix A minus lambda I, and you can put x as this. You'll be getting this. Now solve this. So what will be getting? 9 minus lambda times x1 minus x2 plus 9 x3. Okay, similarly 3 times x1 minus, you can take common, minus of 1 plus lambda times x2, 3x3, and likewise. When you solve this, you'll be getting a system of 3 equations. Okay, now what is our objective? Our objective is to get the eigenvectors for the eigenvalues lambda equal to 0, minus 1 and lambda 2. So let us find out eigenvector for the eigenvalue lambda equal to 0. So what you have to do is, for lambda equal to 0, just put lambda equal to 0 in this set of equation. So for lambda equal to 0, equation A will imply this. Okay, and then once you get this, you can solve any two equation to get the values of x1, x2, x3. Okay, so I will be taking first two equations. So two equation, 3 unknowns. So बहुत ही नाइंसाफी वाली बात हो गई. So what will be taking? Will be applying the Cramer's rule to get the values of x1, x2, x3. So what is x1? x1 would be x1 upon determinant of minus 1 minus 1 9 3 minus x2 upon determinant of 9 3 9 3 and x3 upon determinant of 9 3 minus 1 minus 1. So we'll be getting this. Okay, now solve the determinant. When you solve the determinant, what will be getting? 6 0 minus 6, minus 1 into 3 minus 3 plus 9 6, 63 minus 63 0, and here it is minus 9 plus 3 minus 6. So as you can see, in the denominator we have the values multiple of 6, so just divide by 6. You'll be getting this. So what we have got? We got the eigenvector x1 corresponding to an eigenvalue lambda equal to 0, and that eigenvector is 1 0 minus 1. Now what you have to do is apply exactly similar procedure to get the eigenvector for lambda is equal to minus 1. So for lambda equal to minus 1, again equation A, again we'll take first two equation for the sake of uh, uniformity and then apply Cramer's rule to get the values, okay, of x1, x2, x3, which gives rise to eigenvector x2. Likewise, you can find out on a very similar fashion, you can find out for lambda equal to 2 the eigenvector, and in this case we'll be getting the eigenvector x3 is equal to 4 1 minus 3. Okay, see, we have done nothing. Whatever we have done for lambda equal to 0 and lambda equal to 1, similar thing we are doing for lambda equal to 2. Now once you get the eigenvectors for those eigenvalues, you are now able to write down the modal matrix. What is modal matrix? Just pause the video for a second, recollect the definition of modal matrix, and then try to write down the modal matrix. So what is modal matrix? Modal matrix is nothing but the matrix of eigenvectors, and we have just found out eigenvectors. So the modal matrix is eigenvector, matrix of eigenvector. So this is eigenvector for lambda equal to 0. This is eigenvector for lambda is equal to minus 1, and this is eigenvector for lambda is equal to minus 3. Sorry, 2. Lambda equal to 2. Now as you see, this is what we want in the first part. Now we are done with the first part. Now in the second part, what we have to find out? We have to find out B inverse AB. So we have B matrix A is given. So what we need to find out? We need to find out B inverse. And how one can find out B inverse? Yes, B inverse can be found out by adjoint of B upon determinant of B. So you can make use of calculator or manually you can do, because we have seen how to find out the inverse. Okay, so inverse is this, determinant of this matrix is 1, and adjoint is this. Okay, so for the sake of simplicity I am writing B inverse again. So this is B inverse. Okay, now we have B inverse, we have B, and we have A. So we can certainly find out the value of B inverse AB. Okay, so substitute the values of B inverse A and B. Now just solve this. It will take some time to solve. So what I will do, I will keep this matrix as it is and solve this. So what is it? First row, first column, 9 into 1, 9, minus 1 into 0, 0, plus 9 into minus 1, minus 9. So 9 plus 0 minus 9, 0. So first element is 0. Then first row, second column, what is it? 9 minus 1 minus 9. So plus 9 minus 9 get cancelled, we remain with minus 1. So in this way you can just multiply these two matrices, and whatever matrix you get, then you will multiply with B inverse with that matrix, product of these two matrix. Okay, so the multiplication of this will get this, and then we have to multiply the given equation with B inverse. Okay, so we'll be getting the matrix B inverse AB. Now let me tell you one trick, that don't you waste your precious time in the examination to write down about doing these calculations and all. Just you write down the matrix B inverse AB, you just have write down these three matrix, and you can certainly write this answer, where you will write a diagonal matrix whose diagonal elements are the eigenvalues along the diagonal and rest of the elements 0. Okay, so this will save much of your time in the examination. Okay, we will be always be getting this diagonal matrix as your B inverse AB. Now what happens, sometimes students find out model matrix B nicely, they have found out B inverse nicely, but what happened, they do some mistakes, or not some mistake, so many mistakes in just multiplication of matrices. To avoid that thing, we just put the matrices and write down the final answer. So what is B inverse AB? We got the B inverse AB as a diagonal matrix whose diagonal elements are the eigenvalues. Okay, so this completes the solution of the given problem. So now, as this is mathematics, and the best way to learn mathematics is to do mathematics. So we have a learning by doing activity for each one of you, meaning we have a try this at home problem for you. So we have this example, find the modal matrix B and hence find B inverse AB for the corresponding matrix. Exactly same problem, only the change is we have changed the matrix. Okay, and then the same example can also be asked like this: find the modal matrix B and verify B inverse AB a diagonal matrix. Okay, just the matter of asking the question in different way, but you have to do the same thing whatever we have done in the example number 1. Okay, so this is what we have in this learning video. So enjoy learning digitally, and thank you for watching this learning video. Thank you.